So differentiability is the ability to take the derivative. And when can you take the derivative? Rather, when can you not take the derivative? So one of the rules is if a function is continuous, well, then it may or may not be differentiable. I mean, you may not be able to take the differentiable. I can spell. Okay, so, well, what does that mean overall? So what are some situations? Anything like a sharp turn, like an absolute value of x, okay? Like the absolute value of x alone, here the slope is equal to 1, here the slope is equal to -1. So what's the slope of that sharp turn? Well, it's not 1 or -1. It actually, the slopes would jump, which is like saying a discontinuity for derivatives, so it's not differentiable at any sharp turn. A cusp is another type of sharp turn that looks like this as well, where again, any type of sharp turn you can't. And then one more is what's called a vertical tangent, where the tangent line goes vertical because the slope of a vertical line is undefined. And if the slope is undefined, then that means that the derivative is undefined, and hence it's not differentiable. However, if it's not continuous, well, then it's not differentiable. Okay, so what does that mean? Well, the whole point of differentiability is being able to take the slope at a point. That point doesn't exist, or if it's not continuous, well, then you can't really take the derivative at this instance in time. So if it's not continuous, it's not differentiable. And then lastly, if it's differentiable at a point, then it has to be continuous. If you're taking the derivative across a point, then it has to be differentiable as well. Or rather, if it's differentiable, that means you're finding a tangent line to a point that exists and has to be continuous along that point. So that's the summary of dealing with differentiability. A lot of times you might be asked one of these facts, 1, 2, 3, or it might be some type of visual where you're asked points where it's not differentiable.